Hi, so recently on a live stream somewhere, I think it might have been Big Clive, the subject of laser headlights came up, and I thought, well, that's interesting. I'd vaguely heard of them, so I decided to look a bit further, and I've got this unit on AliExpress. This is a sort of retrofit type thing, sort of single projector type device, and also found this BMW laser headlight assembly on eBay. This one's cheap because it's got broken plastic at the front. I think this is the BMW G20, G21 3 Series, which is obviously a much larger sort of complete unit, so I thought it'd be quite interesting to take a look at them and see how they work and see if there's any scope for repurposing. So the AliExpress unit comes as a pair in this very generic box, no brand name or anything, just some sort of fairly generic information. It's pretty common with Chinese stuff. And this is the unit, is a big fat glass lens on the front. This is clearly designed to fit into some other enclosure, I'm not sure. I suspect maybe this is designed to fit inside certain existing car headlights as an upgrade. Clearly it's not waterproofed at all, so it has to be inside some other sort of enclosure. There's a fan on the back, 4 wires, which are just simple connections for main beam and dip beam. And if you look at it with the without the lens, you can see we've got this big metallised reflector on the top and a LED on this PCB at the top, and a solenoid operated vane here that exposes second LED and a second reflector, and the laser assemblies up in that half main beam. And firing it up, it draws about a little under 4 amps for the initial dip beam, and then with the main beam on, that increases to about 5.7. And if we look at the beam pattern on the floor, a sort of fairly wide flat beam, and then on the main beam we get the sort of centre concentrated beam. Interesting, that flap doesn't really seem to do much outside the width of the so if we look at the light pattern from this, this is a distance of about 8 metres. So this is the normal low beam, and then the high beam, you get this sort of quite hot central section from the laser. So removing this top reflector, we've just got one big high power LED with a thermistor on the PCB, and this is fairly insanely powerful. Full voltage on this is about 20 volts and the current is about 1.5 amps, so it's rather bright, as you can imagine, and it's easily bright enough to scorch a bit of paper at close range. And removing the other cover, we've got this PCB. You can see another reflector over a second LED, and what I think is the laser diode up here. And the other side we've got a smaller LED. This is about half the size. The one on this side has got 6 square areas. I'm not sure if those are 6 individual die or 6 groups of a large number of smaller die in there. And this one's about half the size with 3 groups on it, and the forward voltage of this is about 9.5 volts, so it's about half the number of series die on there. And up here we've got the laser diode, so it looks like what's happening is it's basically firing the blue laser onto the phosphor of this white LED to produce the narrow spot. Let's then focus through the lens to produce a narrow beam. It's not a great deal on this PCB. Unfortunately, you've got the usual stupid Chinese rubbing the numbers off of the chips. We've got this will be a boost converter for the LED. Incidentally, those 2 LEDs are wired in series. There's no individual control over those, so that, for example, when this flap is flipped in front of this side, light from this LED is just blocked out here. It's not turning it off, so it's wasting power. We've got the boost converter for the main LED, so we've got control chip, a couple of MOSFETs and an inductor, and we've got this separate power supply over here for the laser diode, and that's pretty much it. Although there is a microcontroller on here, and I'm struggling to think why. The only thing I can think of is maybe doing the temperature sensing and reducing the output power at high temperatures, but seems a little bit much to actually need a micro. I can't really think of anything else that it's doing. So I wanted to compare the light levels that are coming out of this LED versus what the laser's adding. Now obviously if I just turn it on, it's just going to be ridiculous. You can't see it, it's too bright. It's a bit tricky to get just the laser on because the laser high beam won't come on unless the low beam's also on, which turns the LED on. So I just measured the laser current, which is about 2.5 amps. I'm running that off a separate power supply, so I can now turn the LED on and the laser on independently. Just using this high absorbance filter. So if we just turn the LED on, you can just see that horizontal beam of the LEDs. And with just the laser on, you get a smaller spot. Compare the two, so that's with the LED, that's with just the laser. So it's not quite lighting the full height, so it's maybe a quarter of the linear sort of size between the two. If I turn both on, you can sort of see the LED spot appearing in the middle of it. and that's what's creating the long distant beam using the metallised reflector and the lens at the front. Now, it'd be quite interesting to know if this is actually a special LED designed for this application, because of course if you're firing this blue laser, which is probably maybe a couple of watts at it, there's potentially a lot of power being absorbed. It does look like it's got some sort of ceramic material as its base. That's going to be partly for thermal conduction. Sort of white lead phosphor material. This is a product I think called Chromalit, which is designed for remote phosphor LED lighting, but it's not really up to the power. If I just turn that on, see, we burn a hole in it, make some smoke quite quickly. This is a Chinese chip-on board LED module. This has got like a silicone-y sort of material on the top. See if that will withstand it any better. I'm not seeing the immediate signs of smoke. No obvious burn marks, so maybe this would last a bit longer. So that's pretty much it for this. You know, they're using quite a clever technique. They're just sort of getting a small spot size, which is what you need for a long projection, just by sort of firing a blue laser at an existing LED. It's quite an interesting approach, but it seems to sort of do the job. So the BMW one is pretty large. Obviously it's got multiple light sources. We've got I think probably sort of main beam and dip beam. There's also another source in the side here, and there's also these sort of linear sections, one across here, and one that runs across the whole top. I noticed, say on the back, there's quite a number of pins on this connector. I suspect this uses an external sort of power supply driver type device. There's also a 2-pin connector here, separate 2-pin connector, and there's also there's 2 sections here with a connector. I thought sort of this was a little bit odd, but I noticed there's also a light pipe here, and again this one, there's 2 light pipes, and in fact these are what you use to light up these sort of surround areas. And if I shine some light into this one, you can see it lights up that left hand surround, and this third one does this top section here. And on the side there's this cover which reveals a fan. There's no external venting. This is clearly just to blast some air onto a particular area that then circulates and cools off through the surface. There's no venting or anything out of there. The casing seems to be held together with these clips, but after removing all this, the front isn't moving, and by the look of it there's actually some sort of sealant in between there. This might take a bit of applied violence to get off. Well, that took a lot of effort. Basically the front glass has been glued in all the way around, which basically means any fault on this, or even just a crack in the front thing, and you have to replace the entire thing. You can't just replace the front lens. So I hate to think how much these cost from BMW. They're about, the undamaged ones are about 700 or 800 quid on eBay. A stone chip or something on the lens, it's a bit of an expensive repair. And this is this light guide assembly for the top long strip. The diameter is tapered, it gets thinner towards the end, so obviously it's designed to give an equal amount of light along its length, which is a pretty tricky bit of engineering to get that evenness, especially because it's only lit from one end. It's not like lit at both ends, so they need to get a quite uniform illumination all the way to the end, so it's quite impressive. And this is the other light guide assembly from the small section. Shine a torch through there, we see it's actually made up of 2 sections. We've got the main cylindrical light guide here that seems to be projecting back onto this white material that's then carried forward via this thick clear section. So this is just a clear moulded assembly with some sort of prismatic stuff going on there, just to get the effect. And the light guide, again similar to the other. This one doesn't seem to have much of a taper on it, but there is a bit of a taper on here, so maybe they're using the combination of these to get the uniform illumination, but it's a fairly fancy looking moulding. I'm not quite sure what these marks here are for. I wonder if these are perhaps to break up some internal reflection, to sort of keep the light going this way and avoiding it going sideways perhaps. I don't really know. Right, so having got all that stuff off the front, we can just see there's sort of 2 of these projector units in there. These seem to be on mountings that are fairly adjustable. There are some adjustments, sort of some screw there, and there's a few of these sort of inverse Torx screw thread, another one there, so you can see where this one, for example, comes through, gears across, and then does a forward back adjustment on this, and this is sort of, this assembly is mounted on a pivot. So obviously there's all sorts of various adjustments. Down here I think that's actually a motor that does probably a height adjustment on the on one of the beams as well. Quite a lot of wiring looms in here, and there's this side firing. I'm not quite sure what that is. Maybe it's the front fog, for front fog lights or something. But we can. This looks like it's just a one LED on a metal PCB, so we can fire that up and see what sort of angle that projects at. But I think I'll just try and get these projector units completely out. Okay, so after quite a fight I've managed to get all the modules out of this unit. So this is the sort of simpler one. There's a sort of segmented reflector here and a LED here. This is an Osram LED, it's about 15 watt LED. There's 4 die, maximum current's about 1 amp. That's on an aluminium PCB. Some more LEDs behind this lens. We'll take this off in a sec. But this looks like it's sort of got some sort of segmentation in the glass. It feels like a glass lens. So that's presumably doing like a fairly wide beam. This is doing a more narrow beam. And this is the larger one. Again, we've got a similar LED here, projecting off a partly segmented reflector. And what I'm guessing is the laser source here, which for some reason seems to have this sort of bar in the way. Not quite sure what's going on there. Projecting off this reflector here, and again there's another, it looks fairly similar projection assembly back here. So that's probably a sort of board with a number of LEDs on it on this heatsink. And behind the laser assembly there's some surprising amount of electronics. Now I don't know whether that's maybe some sort of safety systems. They're ultra paranoid that they want it to sort of switch off if they think the thing's got broken or something, but we'll see if we can figure out what's going on there. Seems like quite a lot of electronics just to control a laser diode. And there's a little stepper motor here, and this basically swivels this whole thing sideways. And there's a second stepper motor. This is like a stepper motor with a sort of lead screw in the middle, so this moves up and down, and this tilted both the lights up and down. So this will be the control you get in most cars these days for if you're heavily loaded at the back, you want to tilt the headlights down just to keep them level. And there's this little assembly at the side, so I'm not quite sure what that was, whether it's front fog. This is fairly simple. Surprisingly, it's not an aluminium PCB, it's normal PCB. You might not be able to see it. There's a big array of wires there. It looks like there's 2 die. There's a thermistor and there's another resistor. I'm guessing the resistor is probably some sort of identification or some indication of how much current it wants. And this is the wiring loom. It's a bit bizarre. You've got wiring them this complicated just for a headlight. Now I didn't see any signs of water inside. Obviously it had that hole in the front, so it probably did get water in it, but there is definite signs of corrosion on these connectors, so I'm guessing this probably did actually get fairly full, and perhaps they tried drying it out. Probably enough corrosion on there to probably make it not work. There's corrosion on both connectors as well, so I think there's probably a lot of water in there at some point. And that second connector on the back just seems to go to some part of the loom. There's sort of 2 fairly chunky cables in there, so whether that's distributing power out to something else or a power input, I really don't know. Maybe it's a power input, and there's just a module that goes on here to control all the lights. Actually thinking about it, that's possible, because all these connections are obviously going to go to all the LED drivers, stepper drivers and everything. So I wonder if maybe the module just plugs onto that with no other connections to the car, and then this just provides power and CAN bus to control everything. I think that's probably fairly likely, actually, because obviously you want to have all these cables going on a big loom to the rest of the car. You want to keep all these nice and short, so there's probably a module that plugs in there. Here's an image I found on eBay of the control unit, and this obviously goes on to this round section, so they've put all the electronics into an accessible part. This complete thing is sealed, but at least you can actually get the electronics unit off and replace that if you need to. So let's take a look at this LED unit. So this is about a 15 watt LED in the bottom. Projects a sort of fairly wide beam, and it's actually powerful enough to make some smoke. And just sort of holding your hand in front of it, you can immediately just feel the heat from the light energy coming off of that. And if we take the top part across, we've got this lens at the front, and looks like a sort of reflector. And then we just have this array of LEDs with a moulded lens assembly over the top. So there's a number of smaller LEDs than we saw on the other side, and these just two little ones at the bottom that don't go through the lens. Just lots of big finned cast heatsink. And again, looks like we've got some good sort of thermistor and some ID resistors on that PCB. Again, surprisingly, that's not an aluminium board, it's fiberglass. Big clusters of very small wires around the LED, probably can't quite see on camera. Now, just doing a bit of trial and error on these pins to figure out the connections of these. Surprisingly, they don't seem to be all independently controllable. There's sort of a group of three there in the centre, and then sort of there's three outer ones. And there's those two at the bottom. Incidentally, for doing stuff like this is where the 15 volt diode test mode on this meter is really useful, because these LED strings are around sort of 8 to 12 volts depending on how many LEDs that they got in series. You know, with a standard meter you will probably be able to light up a single LED, but as soon as you have series strings you really need more than sort of 4 or 5 volts, so this is where it comes in really handy. And you can just poke around sort of randomly without causing any damage. I just noticed from these two LEDs here there's actually some light guides that run to the front, so that's probably just giving some sort of accenting. Now, I haven't identified these LEDs, so I don't know what current they're meant to run at. I'll just run them at 200 milliamps to be safe. So we've got this group sort of seems to do the sides but with a gap in the middle, and that one does the centre. So if you join those two together you get sort of one quite wide beam. The other little LEDs with the light guides just do some sort of coloured accents around this blue thing around the side there. Look at how that relates to that single high power LED with its reflector, and this little one just does a sort of wide sort of flat beam, so I think that's maybe front fog light. Other unit, the LED parts are actually very similar. We've got a single LED there going to a reflector, then on this side we've got an assembly very similar to the other one. It's just got three LEDs with lenses, and again we've got two LEDs there going down through this light guide just onto this accent, and then we have the laser module. Okay, so this is the laser module. We've got this board PCB on the bottom, so a microcontroller, CAN transceiver and a power LED driver chip. So this is presumably just going to be handling power control, probably some output control, because there's some sort of opto device here that's got a chunk of, looks like a sort of translucent blue material on top of it, so that's probably a light sensor. But what's puzzling is, yeah, we've got the device here and this sort of piece of metal, and maybe that's reflecting down onto the sensor, but it seems a little odd that there's actually a sort of something directly in front of it. Obviously this works in conjunction with the reflector, so this sits on here like that. If we shine a blue laser at that very small circular, it's about 1 millimeter diameter phosphor, you see it glowing a sort of orangey colour, but with a very small, very concentrated areas. I wonder if maybe one function of this is, if maybe this phosphor end failed, sort of got damaged, I wonder if maybe that's to prevent the blue beam sort of coming straight out the front and actually coming out the front of the headlight. So I wonder perhaps this is a sort of safety thing. So obviously this is made of metal, so even with a fairly powerful beam this isn't going to melt or disappear if it gets hit by the laser directly. So perhaps that's the one of the purposes, as well as to reflect the light down. There's actually two of those sensors. I've unsoldered the laser unit. It's just a 2-pin sort of fairly standard laser housing, although in fact if you look at the top it looks a little bit more elaborate. You've got sort of this top which looks like it's been spot welded on, so there's going to be some assembly with, I've seen some material suggesting there's 3 laser diodes in here, so perhaps there's a range of 3 diodes all firing at this one spot. This sort of seems to be stuck in with some thermally conductive adhesive. On the back of this board there's 2 of these light sensors with these sort of blue glass filters. I think these are probably just attenuators so that they get the sensor in the right sort of range to sense the light that's coming out. Interesting that there's 2 of them. Maybe that's just sort of for extra safety backup or something. There's a couple of inductors for this LED driver chip. Not a great deal else. There's only 4 pins on it, so it's got power and CAN bus going into this, and this LED driver is also software controlled, so you can't tell what the running current is just by looking at the component values, because that's all software controlled. And the circuitry around this driver chip looks pretty much the same as the reference circuit. They seem to be running two channels in parallel. The only difference is there's an N-channel MOSFET on the negative side of the laser diode, which is driven by the micro, so I think that's probably just an additional safety thing. So in addition to be able to control the power on and off via this chip, there's also a secondary control via this MOSFET that can turn the power off. I can't see any obvious signs of anything sort of designed to detect any sort of physical damage other than maybe these sensors. Perhaps it needs to see some sort of balance of the signals. If this sits sort of over here, I wonder if maybe this is designed to reflect the light equally between these two sensors, so if it sees some asymmetry, then that could indicate there's perhaps some physical damage. It can then shut it off before the blue light escapes and take someone's eye out. So let's have a go at powering this thing up. I'm choosing a bench power supply with current limit. I've also just put a 2 ohm resistor in series, because sometimes with power supplies you can get glitches in constant current mode, so I just want to try and give it a little bit of current limiting. So its forward voltage is about 3 volts, so this is about 36 milliamps, and you're just getting a sort of slight small glow. This spot is about 0.7 millimeters, and that's the key to why they use lasers for this. Is the whole point is to get a very intense small spot, and I'll show you in a minute why that's important. I'm not going to crank this up just now to full power because I don't want to risk blowing it till I've done a few tests, but I will do a little bit later. Obviously I don't actually know what its actual current rating is, but the driver chip's got a limit of 1.6 amps per channel, so in theory that could do up to 3.2 amps, although you know I wouldn't expect it to be running at full power, so I think I'll probably try up to maybe 2.5 amps, which will correspond to an input power of about 8 or 9 watts, that sort of figure. So this is a sheet of A4 paper about 3 meters away, and I'm just going to shine it through this lens from the Aliexpress projector unit. So first, this is the conventional lens, and basically at a distance the best you can do is project an image of the actual source. So because the source on this is quite big, this is maybe 5 millimeters wide, the best we can get at that distance is probably about 250 millimeters high as a beam width, and obviously that diverges as you get further away. So if we compare that to what we can get with the laser source, turn this right down because the camera was actually making the spot look bigger than it really was. Let's get this lined up. So at the same distance with the laser source, we've got a spot which is probably about 30 millimeters diameter and nice and circular. So compared to the lead, the spot size is much smaller. And this is the laser using the reflector that it comes within the housing, so that's sort of vaguely, it's not a completely round beam, but it's sort of fairly well focused. Let's try a slightly bigger distance. I've set up both the laser and the conventional headlight using its normal optics, and this is shining distance of about 9 meters to my garage door. So this is the laser at the bottom and the main beam at the top. So with a simple lens for the LED, high power LED, again a distance of about 8 or 9 meters, we've basically got an image of the 4 LED die here. So I'm holding this lens by hand, so it's a bit hard to get it lined up properly, but say we've got an image of the 4 LED die, and that's probably about good half a meter high by about maybe sort of 150 to 200 millimeters wide if it was perfectly lined up. If we compare the laser source, we've got a spot. The camera's probably, there's a sort of a bright centre and a bit of a haze around the outside, so the camera's probably just seeing the haze, but the actual focus spot I guess is probably around the sort of 60 or 70 millimeters diameter, so we get a much more intense beam, and obviously that will go a hell of a long distance. So this is a very neat little device. I'm fairly sure this assembly is sort of custom made for this application. Probably Osram, because I've seen some Osram information about using sort of their laser diodes as white sources. I did find this device from Kyocera, who make sort of completely integrated surface mount laser source. which looks potentially quite interesting. And if you look at their sort of spec sheets, they've got devices up to 1000 lumens, which is in the same sort of ballpark as these sort of high power LEDs here, but of course a much more concentrated beam. So the main application here is where you need a super small source, either because you want very narrow beam projection, also if you want to couple it into an optical fibre, it's a lot easier to do with a small light source. But I think this may need to be integrated into a torch or something interesting, have a bit of fun with. So a surprisingly complicated assembly for what is just sort of lighting cars. We've got all these funky light guides and stuff going on, lots of ridiculously complicated mouldings, motorised lights. I believe these would actually sort of follow the line of the road as well. I was trying to find the cost of the laser option. There's a few websites mentioning sort of €8,000 and so on, but I think that might have been from a while ago. I think it was on the i8. Looking at the BMW UK website, on the 7 Series it looks like it's about £1,500 option for the laser headlights. It'll be interesting to see whether we see these sort of coming onto lower end cars, because the actual laser part of it is only a sort of fairly small part of the overall headlight assembly. But I think we may well see these laser-based light sources in other applications, like very small spotlights and other sort of scientific applications where we need to get a very bright light onto a fibre and so on.